Good afternoon, Engineer Catholico, and good afternoon, classmate. Today we will discuss the Chapter 14, Optical Properties, presented by Belen John Paul, Lacanaria Mark Anthony, and Tabila Kane Adrian. Basic concept. Engineering materials are important in every life because of the versatile structure properties. Other than these properties, they do play an important role because of their physical properties. Prime physical properties of materials include electrical properties, thermal properties, and magnetic properties, and optical properties. The optical properties of engineering materials are useful in different applications, example domestic, medicine, astronomy, manufacturing. Based on sa basic concept, napakalaki ng ginagampanan ng optical properties dahil na din sa katangian nito like thermal properties, magnetic properties, and optical properties. Yung thermal properties is related siya sa conductivity of heat, which refers to the heat that passes through materials. Yung magnetic properties naman ay tumutukoy sa strength and direction ng magnetism. Sunod naman is yung fiber optic cables. Ito yung mga ginagamit natin para mas mabilis na mag-transmit ng data from another. Sunod is yung fiber optics in medicine. Ito yung mga ginagamit sa mga operation na lalo na pag sa loob ng katawan. Kung saan yung tong fiber optics in medicine, meron siyang camera or lens na nakakakita or siya yung nagga-guide lalo na kung internal yung operation na kung saan doon nakikita sa camera yung kung ano yung nakikita rin nung fiber optic natin na lens dun sa loob ng katawan ng patient. Yung sunod naman is yung optical lenses in astronomy. Ito naman yung parang lens siya kung saan siya yung nakakakita kung ano yung mga dun sa outer space. Tapos, itatransmit niya yun para makita natin doon sa mga computer sa NASA or sa mga space station. Sunod, manufacturing. Ito yung mga gumagawa ng mga fiber optic cables or di kaya yung mga fiber optic medicine or di kaya yung mga optical lenses ng astronomy. Optical properties of materials is defined as interaction with electromagnetic radiation in the visible. Electromagnetic spectrum of radiation spans the width range from Y rays with a wavelength of 10 to 12 meters through X-ray, ultraviolet, visible, infrared, and finally radio wave with the wavelength as long as 105 meters. With visible light is the one form of electromagnetic radiation with the wavelength ranging from 0.39 to 0.77. Light can be considered as having waves and consisting of particles called photons. Optical properties is tumutukoy siya sa isang materials na kung saan ay napag-uugnay nito yung mga visible lights na kung saan ay nagkakaroon ng refraction, na kung saan ay nagkakaroon ng pag-bend ng light passing to the transparent substance into another. Next, radio wave has at least amount of energy and then the lowest frequency. When radio waves impinge upon a conductor, they couple the conductor travel along it and induce an electric current on the conductor surface by moving the electrons of the conducting materials into correlated branches of charge. Tells that na yung radio waves ay mayroong at least one least of energy with lowest frequency na kung saan ay nagtatravel sila papunta sa electrical charge. Infrared radiation is used in industrial, scientific, military, commercial, and medical application. Night vision devices using an active near-infrared illumination allow the people and animals to be observed without the observed being detected. Para siyang isang device kung saan nadedetect niya yung mga object or tao nang hindi sila napapansin. Para siyang heat sensor kung saan nadidetect niya yung mga possible na interaction doon sa isang place. Next, as the frequency increase into ultraviolet, photons now carry enough energy, about 3 electron volts or more, to excite certain dowdly bounded molecules into permanent chemical rearrangement. Dito, pinapakita na once na nag-i-increase na yung frequency ng ultraviolet, yung photons ngayon ay nagkakaroon na ng enough energy para o di kaya mag-release siya ng 3 electron volts or more para makomplete niya yung molecules bonds para magkaroon na ng permanent rearrangement ng chemicals. Electromagnetic radiation. EM radiation or electromagnetic radiation is a form of energy propagating where photons with both particles and wave-like properties travel at the speed of light. EM waves carry energy and transfer their energy upon interaction with matter. The energy associated with the EM radiation is proportional to frequency and inversely proportional to wavelength. Thus, EM waves with shorter wavelengths have more energy. Example of EM radiation from lowest to highest energy include radio waves, microwaves, infrared, visible lights, and UV and radiography. Yung electromagnetic radiation ay isang radiation na kung saan mayroon itong electric and magnetic field na nagta-travel into waves na kung saan dito may kita yung strength from low energy to high energy. Example nito is yung radio waves. Yung radio wave has the lowest energy but has a long wavelength. Tapos dito sa diagram makikita mo yung wavelength ng mga radiation from lowest to highest. Tapos dito pertaining sa visible lights, makikita rin natin yung wavelength ng mga colors from lowest to highest. Optical properties refers to the material's response to exposure to electromagnetic radiation and in particular to visible lights. Light has both particulate and wave-like characteristic. Photon, a quantum unit of light. Yung electromagnetic radiation ay isa siyang uri ng visible light. Tapos naman yung photon is yung nagkikerry siya ng energy proportionally to the radiation frequency. Tapos dito sa baba, makikita natin yung formula ng electromagnetic spectrum. Yung E is refers to the energy of a photon. Next is yung parang Y na nakapabaliktad, yung wave, which refers to the wavelength of radiation. B is for the frequency of radiation. H for the Planck constant, 6.62 times 10 raised to negative 34 joule per second. C is the speed of light in a vacuum, 3 times 10 raised to 8 meter per second. Light sheets or radiation energy, radar, radio waves, and X-ray are all forms of electromagnetic radiation. Next is yung light interaction with solid materials. Interaction of photons with the electronic or crystal structure of material leads to a number of phenomena. The photons may give their energy to the material's absorption. Dito sa peak 1 o yung sa unang-una, nakita natin na yung pag yung light na interact niya na yung solid materials, nagkakaroon lang sila ng absorption doon sa solid materials na kung saan hindi siya nagpassing through doon sa kabilang surface nung solid materials. Next is yung photon gives their energy but not photons of identical energy are immediately emitted by the materials. In short, reflection. Dito naman sa pangalawa, yung nagkakaroon lang siya ng reflection or bigla na lang nag-bounce back yung light na nakuha niya doon, yung light na tumama doon sa may solid materials. 3. Or photons may not interact with the material structures called transmission. Dito, kumbaga, hindi niya nagkaroon sila ng interaction. Ang nangyari lang is nagpassing through lang yung light papunta dun sa may solid materials nang walang nangyayaring interact. 4 is during transmission, photons are changes in velocity, in short, refraction. Kumbaga, ang nangyari niya, once na nagkaroon ng interaction yung light tsaka yung solid materials, nagkakaroon ng pagbagal bigla nung pag-travel nung light, kaya siya nagkakaroon ng refraction bago siya tumagos dun sa kabilang section nung surface nung isang solid materials. Optical properties of metals. There are opaque of visible light due to crystallinity but are transparent to high frequency radiation, X-ray and gamma radiation. The incident radiation having frequency within the visible range excites the electron into an occupied energy state above the Fermi energy. All frequencies of visible lights are absorbed by metals because of this continuously available empty electron states which permit electron transition. In short, na kapag mas mataas yung frequency, nakakapag-release siya ng visible lights na kung saan yung photons ay directed sa metals at yung energy niya ay ginagamit to excite electrons into an occupied state, na kung saan kapag na-absorb na ng metal yung radiation, maglalabas ito ng metallic surface para makabuo ng visible light na may kaparehong wavelength. Next is ito yung radiation and penetration ng X-ray machine sa gamma rays. Dito may ilang example ng mga materials at dito may kita yung pag-transfer ng light. Pag alpha lang, kaya nyo lang hanggang dun lang siya sa may paper. Pag beta naman is tatago siya between sa paper tsaka sa thin plate made of wooden na aluminum. Pero pag X-ray tsaka gamma rays is kaya niyang tagusan yung paper, thin plates made of wood and aluminum papunta lang sa lead, iron, and other thick metal plates. Pag neuron naman is kaya niyang tagusan yung tatlong iyon papunta doon sa water or concrete, na kung saan yung neutron ay isa siyang form ng ionization radiation, na kung saan nagpe-present siya as a free neuron, na kung saan isa siyang nuclear fission or nuclear fusion causing to release of free neutrons which react with nuclei or other atoms to form a new isotopes. Optical properties of nonmetals. Non-metallic materials consist of various energy band structure. Thus, all four of optical phenomena are important. They may be transparent, translucent, or opaque. Application examples are glasses, plastics, and semiconductors. Kung saan, dyan sa may optical properties of non-metals, nagkakaroon siya ng refraction, na kung saan nagkakaroon ng pagbend ng light passing to the transparent substance. Parang katulad nung kaninang nandun sa isang slide, nagkaroon lang sila ng refraction. Sunod din dyan sa optical properties of metal, meron din dyang reflection, na kung saan nagbabounce back lang yung light, kaya niya nagagaya yung original surface and angle nung isang object once na tumama lang yung light doon sa isang materials. Sunod is yung absorption. In short, na nagtitake or siya yung kumukuha ng ibang substance para makapture and matransform into energy. Kumbaga dito nagkakaroon lang sila ng pagtake ng mga substance para ma-convert sila sa energy. Sunod naman dito sa optical properties of non-metals is yung meron din silang transmission, kung saan ay na-transmit yung light papunta lang dun sa surface papunta doon sa kabilang surface ng isang object. Kumbaga, diretso lang siyang transmission doon sa isang solid object. Na kung saan yung optical properties of metals is yung non-metallic materials may absorb, reflect, and refract or transmit lights depending on their electrons and energy band structure. Tulad dito dun sa may plastic bottles, pwede siyang magkaroon ng na kung saan pwede siyang magkaroon ng deflection tulad nung nandito sa picture na nagaya niya rin yung same angle nung bote with the same wavelength nung tumamang light sa kanya. Tapos, dito naman sa baso, kung makikita natin, nagkaroon ng transmission na kung saan diretso lang dumaan yung ilaw sa kanya. Pero meron din yung mga reflection pag ibang angle na yung tinamaan nung light.
Next is refraction. Refraction is when light that is transmitted into the interior of transparent materials experience a decrease in velocity and, as a result, is bent at the interface. This phenomenon is termed refraction. This can happen when adding large ions to glass decreases the speed of light in the glass. Light can be bent as it passes through transparent prism. Katulad ng nangyari dito sa figure sa baba, nung nag-pass yung light sa transparent prism, nag-decrease yung speed niya na naging resulta ng pagka-bend nung ilaw. The index of refraction N of a material is defined as the ratio of the velocity in a vacuum C to the velocity in the medium V. Therefore, we can say that N is equal to C over V, where N is the index of refraction, C is the velocity of light in vacuum, and V is velocity of light in medium. Meron naman tayo ditong example ng mga materials at yung equivalent na index of refraction niya. Isa dito is yung typical glasses. Meron siyang index of refraction na 1.5 to 1.7. Next is plastics na meron 1.3 to 1.6. PBO 2.67 and diamond na meron 2.41. Next, meron tayong table na nagpapakita ng refractive indices ng transparent materials. Note that in ionic materials, the larger the size of the component ions, the greater the degree of electronic polarization and the higher the N values. Next, reflectivity of nonmetals. For normal incidence and light passing into a solid having an index of refraction N. Gagamitin natin dito yung formula na R is equals to IR over IO is equals to N minus 1 over N plus 1 squared. Meron tayo ditong example. For diamond N is equals to 2.41 ang kanyang index refraction. Ngayon, isa-substitute natin yung 2.41 na yon sa N. Kaya magiging R is equals to 2.41 minus 1 over 2.41 plus 1 squared is equals to 0.17. Therefore, 17% of light is reflected. So, ganun ang pagkuha ng reflectivity ng mga nonmetals. Next, difference between reflection and refraction. There is a unique difference between reflection and refraction, and it is important to analyze both these terms and understand the definitions of both these terms. Reflection is simply the property of light that rebounds after hitting a surface. When the light that passes through a surface undergoes some changes in the appearance. Sabi dito, ang reflection ay ang pagtalbog ng ilaw after netong tumama sa isang surface. Samantalang sabi kanina sa definition ng refraction, ang refraction ay ang pag-bend o ang pag-divert ng ilaw matapos nitong dumaan sa isang transparent na bagay. Sa reflection, kapag ang ray na tumama sa isang surface ay tinatawag na incident ray. Ngayon, kapag ang ray na tumalbog galing sa smooth surface, ito ay tinatawag na reflected ray. Kapag ang angle naman sa pagitan ng incident ray at ng normal ray, ito ay tinatawag na angle of incidence. At ang angle naman sa pagitan ng normal ray at reflected ray, ito naman ay tinatawag na angle of reflection. Ang mga sumusunod na larawan ay ang mga halimbawa ng mga reflection. Next, meron tayo ditong table na nagpapakita ng difference between reflection and refraction. Sa reflection, this phenomenon usually occurs in mirrors, while sa refraction, this phenomenon usually occurs in lenses. Reflection can simply be defined as the reflection of light when it strikes the medium on a plane, while refraction can be defined as the process of the shift of light when it passes through a medium, leading to the bending of light. The reflection, the light entering the medium returns to the same direction, while sa refraction, the light entering the medium travels from one medium to another. Sa reflection, considering the light waves, they bounce from the plane and change direction, while sa refraction, the light waves pass through a surface while simultaneously change from medium to medium. Sa reflection, the angle of incidence of light is equal to the angle of reflection. Sa refraction, the angle of incidence is not equal to the angle of reflection. Next, meron tayong mga pictures na nagpapakita ng example ng refraction at reflection. Sa refraction, magandang halimbawa nito yung pagtagos ng ilaw sa tubig na nagiging dahilan para magmukhang nasa ibang lugar ang mga bagay nasa ilalim ng tubig. Habang sa reflection naman, sa pinakamagandang halimbawa nito, yung salamin. Next is light absorption. The fraction of beam that is absorbed is related to the thickness of the materials and the manner in which the photons interact with the material structure. Ito yung pag-penetrate ng light energy sa isang bagay. Typically, yung light energy na yun ay nako-convert sa heat. Absorption occurs by two mechanisms, Rayleigh scattering and Compton scattering. The amount of light absorbed by a material is calculated using Bohr's law. So ito yung mga formula na gagamitin natin kung gaano kataas ang light na na-absorb ng isang material. Next, Rayleigh scattering. Where photon interacts with the electrons, it is deflected without any change in its energy. This is significant for high atomic number atoms and low photon energies. Example, blue color in the sunlight gets scattered more than other colors in the visible spectrum, and thus making the sky look blue. So sa given picture sa ibaba, makikita natin dito yung iba't ibang kulay ng sunlight. At kung papansinin natin, mas naikakalat ang kulay asul na nagiging dahilan kung bakit kulay asul ang langit. Next ay Compton scattering. Compton scattering describes the situation in which relatively low-energy photons emitted from the isotope pass through the tissue and collide with molecules, producing a change in direction and some loss of energy. So dito meron tayong example ng Compton scattering. Next, difference between Rayleigh scattering and Compton scattering. So ito yung mga ilan sa mga pinagkaiba ng Rayleigh scattering at Compton scattering. Rayleigh scattering is the scattering of light by particles much smaller than the wavelength of the radiation. The scattering can occur of atoms or molecules, and for molecules, the scattering can be inelastic with a change of rational energy of the molecule. Compton scattering is the scattering of photon by a charged particle. Next, Rayleigh scattering is elastic, while Compton scattering is inelastic. Rayleigh scattering is parametric process. Do not change the state of the material, while Compton scattering changes the energy of the photon. Next, color. Color, also spelled color. The aspect of any object that may be described in terms of hue, lightness, and saturation. In physics, color is associated specifically with electromagnetic radiation of a certain range of wavelengths visible to a human eye. Radiation, such as wavelengths, constitutes that portion of the electromagnetic spectrum known as the visible spectrum. Next, opacity and translucency depends to a great degree on their internal reflectance and transmittance characteristics, interior reflection and refraction, diffuse as a result of multiple scattering events. Opacity results from extensive scattering that virtually none of the incident beam is transmitted. Dito meron tayong larawan na nagpapakita ng pinagkaiba ng transparent, translucent at opaque. Ang mga transparent na bagay ay hinahayaang makatagos ng maayos ang ilaw, samantalang ang translucent naman ay iilan lamang ang ilaw na nakakatagos dito, habang ang opaque naman ay hindi nahahayaang makatagos ang ilaw dahil sa mga characteristics netong makapag-reflect at makapag-absorb ng ilaw. Next, application and differentiation. Materials are classified on the basis of their interaction with visible light in three categories. Ito yung na-explain natin kanina na transparent, which is all light passes through, translucent, some light passes through, at opaque, no light passes through. Materials that are capable of transmitting light with relatively little absorption and reflection are transparent. Those materials through which light is transmitted diffusely, that is, light is scattered within the interior, to the degree that objects are not clearly distinguishable when viewed through a specimen of the material, are termed as translucent. Next, applications of optical phenomena. Light interacts with a material in many ways. Depending on the material, its crystal or microstructure, and also on the characteristics of incident light. There are many peculiar phenomena occurs, which are known as optical phenomena. So, yung optical phenomena, ito yung mga pangyayari kung saan visible yung interaction ng light at matter. Next, meron tayo ditong mga examples ng optical phenomena. This include luminescence, lasers, photoconductivity, optical fibers. All these find quite many applications in technology for everyday life. So sa mga given examples, makikita natin na visible ang light after ng interaction nito sa matter. So that's all for chapter 14. Thank you for listening. I hope you learned something.